Hello everyone. Welcome to today's lecture on cloud networking, part of our cloud computing course IT 4090. Today we're going to dive into a range of important topics that are key to understanding how networking functions within cloud environments. Our session will cover everything from basic networking concepts to advanced topics like software-defined networking, SDN, network function virtualization, NFV, virtual networks, and more. Let's get started with a quick networking recap.
Networking recap. Before we delve into cloud-specific networking, let's revisit some fundamental networking concepts. IP addresses. These are unique identifiers assigned to devices on a network, allowing them to communicate with each other. Subnets and VLSM. Subnets divide a larger network into smaller, more manageable segments, and variable length subnet masking, VLSM, allows for efficient IP address allocation. Basic routing. This involves the process of determining the path data packets take from one device to another across networks. Default gateways. These are nodes in a network that serve as access points for sending data from a local network to other networks.
Software-defined networking, SDN. Now let's move on to software-defined networking, or SDN. SDN is a network management architecture that enables dynamic and programmable network configuration, which in turn improves network performance and monitoring. This architecture decouples the network control and forwarding functions, allowing the network control to be directly programmable and abstracting the underlying infrastructure for applications and services.
Network Function Virtualization, NFV. Next up is Network Function Virtualization, or NFV. NFV is a network architecture that decouples physical network functions from proprietary hardware appliances, enabling them to run as software in virtual machines, known as Virtual Network Functions, VNFs. Examples of VNFs include firewalls, traffic control, and virtual routing. The successor of VNFs is Cloud Native Network Functions, CNFs, which are software implementations of physical network functions running inside Linux containers. Advantages of CNFs include auto-scaling. CNFs can scale automatically based on demand. Speed and efficiency. CNFs are quicker to deploy and more efficient than traditional VNFs. Deployment with DevOps and CI/CD. CNFs can be integrated seamlessly with DevOps practices and continuous integration/continuous deployment pipelines. Security and monitoring. CNFs allow for robust security measures and continuous monitoring.
SDN versus NFV. While SDN and NFV share similarities, such as network abstraction and heavy reliance on virtualization, they also have key differences. SDN separates network control functions from forwarding functions, focusing on the big-picture infrastructure management. NFV abstracts all network functions from the underlying hardware, delivering a wide range of specific functionalities. Both play vital roles in modern cloud networking by enabling more flexible, scalable, and efficient network management.
Virtual networks. Cloud networking services like AWS Virtual Private Cloud, VPC, and Azure Virtual Network provide networking functions to cloud resources. These virtual networks are logically isolated from other virtual networks and have one or more IP ranges. They also contain one or more subnets and can be peered with other virtual networks, provided the IP ranges do not overlap.
Subnets. Subnets further segment a virtual network's IP range. Subnet CIDR, classless interdomain routing blocks, cannot overlap within a virtual network. Traffic within subnets can be restricted using access control lists, ACLs. AWS offers both private and public subnets. Instances in public subnets can send outbound traffic directly to the Internet, while those in private subnets cannot. Azure does not distinguish between public and private subnets, but similar functionality can be implemented using route tables. Subnet IP reservation examples. 10.0.0.0/24. First usable IP is 10.0.0.04, and the last usable IP is 10.0.0.0254, providing 251 usable IPs. 172.16.10.128/25. First usable IP is 172.16.10.132, and the last usable IP is 172.16.10.254, providing 123 usable IPs. 192.168.0.64/27. First usable IP is 192.168.0.68, and the last usable IP is 192.168.0.94, providing 27 usable IPs.
Virtual network interfaces. A virtual network interface is a logical networking component representing the Network Interface Card (NIC). It enables a compute instance to communicate with other compute instances and/or the Internet. Multiple virtual network interfaces can be attached to a single compute instance, each potentially having one public IP and multiple private IPs. Examples: AWS, Elastic Network Interface (ENI), Azure, Network Interface Card (NIC).
Access controlling. Access control in cloud networking is akin to implementing a simple firewall that controls inbound and outbound traffic to a subnet or virtual network interface. Access control lists (ACLs) define rules that specify protocols, port ranges, IP ranges, and allow or deny actions. Usage in CSPs. AWS security groups. Assigned to an EC2 instance. AWS Network Access Control List. NACL assigned to a subnet. Azure Network Security Groups. NSG can be assigned to both subnets and NICs. Stateful versus stateless rules. Stateful rules only specify the rule for the request, as the response is automatically allowed. Stateless rules need to specify rules for both the request and the response.
Network Gateway Services. Network gateway services are virtual network functions that provide connectivity between cloud resources and external networks or the Internet. Key services include Internet Gateway, provides connectivity between the Internet and the virtual network, scaling horizontally without bandwidth constraints. Example, AWS Internet Gateway, NAT Gateway, provides network address translation (NAT) to compute instances in private subnets, preventing connections initiated from the Internet. VPN Gateway creates encrypted tunnels over the public Internet to send traffic between virtual networks and on-premises networks.
VPN services. Cloud service providers, CSPs, offer different types of VPN services. Site-to-site VPN connects a virtual network with an on-premises network or another virtual network. Point-to-site VPN connects a virtual network with a client PC using special client VPN software. Azure provides both site-to-site and point-to-site VPN connectivity, while AWS offers site-to-site connectivity through its virtual private gateway and point-to-site connectivity through AWS Client VPN.
Network Transit Gateway. Network Transit Gateway is a service that connects multiple virtual networks and on-premises networks through a central hub. This architecture, often referred to as the hub-and-spoke model, is implemented in services like AWS Transit Gateway and Azure Virtual WAN.
Network peering. Network peering allows you to connect and communicate between two virtual networks. It was previously implemented using VPN gateways. Each virtual network can be peered with multiple other virtual networks, but transitive peering is not supported, meaning if VNet A is peered with VNet B, and VNet B is peered with VNet C, VNet A cannot communicate with VNet C and vice versa.
Bastion hosts. A bastion host, also known as a jump host, is a special compute instance deployed to provide secure management access to other compute instances in private subnets without exposing them to the internet. The bastion host is placed in a public subnet and given a public IP to facilitate the secure access.
Hybrid connectivity. For hybrid connectivity, there are various ways to connect to a virtual network in the cloud. Connecting remote users. Through direct internet connectivity, VPN, Azure Point-to-Site VPN, or AWS Client VPN. Connecting remote networks. Through site-to-site VPN, direct connectivity, Azure ExpressRoute, or AWS Direct Connect.
Private access to cloud services. Private access to cloud services allows secure access to past services of the CSP without traversing the public internet. This is achieved through private links and private endpoints. Private links provide access between other resources in the virtual network and past services. Private endpoints provide secure and direct connectivity to Azure PaaS services over an optimized route within the Azure Backbone network.
Network flow logs. Network flow logs capture information about IP traffic entering and exiting your network interfaces in the virtual network. This log data is collected outside the network traffic path, meaning it doesn't affect network throughput or latency. The log data can be stored in separate object storage, AWS S3/Azure blobs, and is useful for troubleshooting connectivity issues, intrusion detection, and ensuring compliance with legal or regulatory requirements.
That concludes our detailed exploration of cloud networking. We've covered a broad spectrum of topics, from basic networking principles to advanced cloud-specific networking concepts like SDN, NFV, virtual networks, and more. These principles are foundational to anyone working with cloud infrastructure, and I encourage you to study them further and apply them in your projects. Thank you for your attention, and see you in the next lecture.